Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, we are going to work on what you need to know for analytic trigonometry. So this is the next unit in our pre-calculus class, and I just wanted to go over some common problems and processes that will help you prepare for the chapter in analytic trigonometry. So what we're going to do is we're going to work on rationalizing the denominator. We're going to work on simplifying and applying some operations, adding and subtracting rational expressions, as well as simplifying like a complex fraction and just, fractions just with numbers. Then we're going to practice solving quadratic equations using different techniques such as the square root method and factoring. And then we're going to work on evaluating the three trigonometric functions based on the unit circle. So again, this is not a complete list of everything you should know before getting into analytic trigonometry, but just some common types of problems that I think going through this worksheet is going to give you a good foundation and help prepare you for the types of problems that you are going to see in this unit. So let's go ahead and get started. All right, so on question number 1, rationalizing the denominator. Now, this is something that we worked in our last unit. I talked to students about how we're going to practice simplifying all of our answers by making sure that we do not leave a radical in the denominator. And to get rid of the radical in the denominator, we're just going to multiply by the square root of 3 on the bottom and the top. And you got to make sure you multiply on the bottom and the top to produce an equivalent fraction. It is important, though, to notice in this case we have a binomial in the numerator. So therefore, we need to make sure we distribute that square root of 3. So therefore, we end up with a 2 radical 3 plus the square root of 3 times square root of 3 is 3 all over 3. We want to be careful. We don't want to divide out these 3's, right? Because this 3 is divided into both of these quantities. So you could write it like this, or, some students will see, it could also be written like this, where you could divide that 3 into both of them. This chapter, I think the tough thing about this chapter is there's a lot of different ways we can write the answer. And it's difficult because when we get into, multiple choice type of questions, like all 3 of these could be answer choices, right? So you just have to make sure you understand how you can, different forms of each answer. But typically for simplicity purposes, I'll usually just leave it as one fraction. That's fine with me. But it's important to sometimes understand distributed or rewriting as multiplication with a fraction. Now, the next problem is here. If I was going to do my, rationalize the denominator, most people are like, all right, well, it's square root of 2, just like you did before. But the problem is, since there's a binomial in the denominator, you're always going to have a radical, right, in this denominator, because square root of 2 times 1 is square root of 2, and then you get rid of the radical here. So remember, the purpose of rationalizing the denominator is to get rid of the radical. So what we're going to do is want to multiply by the conjugate. So the conjugate of 1 minus square root of 2 is 1 plus the square root of 2, and then 1 plus the square root of 2. Now, it's important to understand what this conjugate is going to do. You see that these are the exact same binomials, just one's negative, one's positive. Well, what that is going to produce is a difference of 2 squares. And if you remember the factored form for a difference of 2 squares, that's basically a squared minus b squared. So we can just square the first 2 terms, subtract that from the square of the second 2 terms. So that helps us out and makes things go by a little bit quicker. If you're not up to that point and you actually want to multiply them out, then please go ahead and do that, and that's fine. You'll get to the same answer. I think even for this one, I'll maybe just multiply it out so therefore you can see how it works. And then for the next ones, because moving on, we'll just kind of go through the simplified answer. The top here, I definitely need to distribute. And then here you could kind of do what we call like the FOIL, right? That's going on. So up top here, I'm going to have 4 times 1 is 4, plus 4 times the square root of 2. All over, let's just expand everything. So 1 times 1 is 1, plus 1 times the square root of 2. Negative square root of 2 times 1 is going to be a negative square root of 2. And negative square root of 2 times positive square root of 2 is just going to be a negative 2. So what you can see is these middle terms, these actually simplify out. So therefore, that's going to be left with 4 plus 4 square root of 2 all over 1 minus negative 2, which is just a negative 1. Now, we could leave it like this, or you could distribute that negative 1 into both of those terms to give you a negative 4 minus 4 square root of 2. But either way, I just want you to see how, again, that difference of squares work. 1 squared is 1, and square root of 2 squared is 2. And then you're just subtracting the 1 minus the 2. And that's how that ended up giving us that negative 1. So in this next case, we're just going to, again, multiply by the conjugate. In this case, we just have a binomial in the numerator and the denominator, but that's fine. We're just going to follow. We want to get rid of the radical in the denominator. That's our main key. So we're going to multiply by this conjugate. Now the nice thing is, in this numerator, what we recognize, this is actually the exact same binomial times itself, right? They're exactly the same. So remember, that's going to produce a perfect square trinomial. And if we had like a minus b, really it's a minus b times a minus b, or a minus b squared, that's going to give you a squared plus, I'm sorry, same sign, minus 2ab plus b squared. So if you can, that is just that factoring technique of a perfect square trinomial. So rather than doing all the time factoring out, I know that this is going to give me a 9 minus 2 times 3, which would be 6. So that's going to be minus 6 times the square root of 5. And then minus square root of 5 squared, which is going to be, or I'm sorry, that's going to be a positive 5. Positive 5. And then let's go ahead and, yeah, because that's going to be a positive b squared, and b in this case is square root of 5. So square root of 5 squared is just going to be 5. Then in the denominator, I have a difference of 2 squares, so I'm going to follow that technique. So that's going to give me a 9 minus 5. All right, now I can just go ahead and simplify my work here. Let me just make sure I had 3 times 2 times 3 times square root of 5. Yeah, and that's going to be negative. Good. So 9 plus 5 is going to be 14. So I have 14 minus 6 square root of 5 divided by 9 minus 5 is going to be 4. Now I can't divide the 4 into both these terms, but I can divide everything out by 2. So we could simplify this one more time. If I just divided everything by 2, I would get 7 minus 3 square root of 5 divided by 2. And therefore we could leave it like this, or we could use one of those other variations from there. But I'm just going to leave that in the simplified form. So that's the main idea with rationalized denominator. Previously, we did this to eliminate the radical in the denominator, but in this chapter, we're going to use it to help simplify our expressions. All right, so the next one is, talk about simplifying expressions, is simplifying rational expressions. And for the first two examples, you know, really just this main key is practicing factoring, factoring, and factoring. All right. So we can't divide out the ones. You know, we have to, when we're simplifying, we have to make sure that our quantities are separated by multiplication. So that's why we want to factor. There's nothing we can factor in the denominator here, but in this numerator, we can factor this as the difference of two squares, x minus 1 times x plus 1, all over x minus 1. Now you can see that these quantities are separated by multiplication, so I can divide out the x minus 1s. Just leave me with a x plus 1 as the simplified expression. So we're not going to talk about wholes and asymptotes, you know, and all that kind of stuff, but just practicing that rewriting at factoring, so therefore you can simplify them. In this next case, we want to make sure when we are factoring, this is for trinomials or binomials, to make sure you just have things written in your standard form. So for instance, I like to write this as a negative 4x plus 4 divided by x plus 2. And then you can just factor out the negative to an x squared minus 4 all over x plus 2. So now you can see, okay, so now I factor out the negative. Now again, I have another difference of two squares. So that's a negative x minus 2 times x plus 2 all over this x plus 2. Now my x plus 2's divide out, and I'm just going to be left with a negative x minus 2, which could be distributed to give me a negative x plus 2. Okay, so again, just remember, you know, as you're simplifying, sometimes simplifying is not as obvious, so you might need to rearrange the terms before you can go ahead and simplify them. Then we are going to be adding some fractions. So a couple key points to remember when you're adding some fractions. Basically, we've got to have common denominators. I'm sorry, adding and subtracting fractions. In this case, we're subtracting. And we just don't have, you know, integers as our denominator. We have these expressions. So remember, the fastest and easiest way to identify a common denominator is just to multiply the denominators. Now, this is something we worked on in our rational functions chapter. And basically, I kind of explained it, and so I'm not going to go through the whole step here, but we want to identify the LCD. And a quick way to always identify the LCD, or at least a common denominator, is just to multiply the denominators. And so therefore, you can see that the LCD in this case, or at least the common denominator, is x plus 5, x minus 5. So therefore, to obtain common denominators, I'm just going to multiply here by x plus 5 over x plus 5, and here x minus 5 over x minus 5. All right. Now, we can simplify this. So therefore, this is going to be x minus 5 all over x minus 5 times x plus 5. Now be very careful and remember this is a negative 2, right? So what I'm going to do is I'm going to rewrite this subtraction as an addition problem. So I'm going to rewrite this as a positive negative 2 times x plus 5. So instead of writing, plus and negative is the same thing as subtracting. But this just allows me just to go ahead and x minus 5 times x plus 5. Now I can apply this division here. And you can see that my denominators are the same. So therefore, I can just go ahead and combine the numerators, and then put them over a common denominator. So I'll just write this as, it's right here. So I'll write this as an x minus 5 plus, let's see, negative 2x minus 10. And it's really, really important that you recognize here this, that you recognize that negative 2, first of all, that it's a negative, and you have to multiply it by the x and the 5. A lot of students will just make the mistake and they'll just leave a negative 2x plus 5. But you got to make sure you apply that distributive property. We don't really need this plus a negative 2x. We could just write minus 2x, but I'll leave it there just for the sake of accounting purposes. Then we have x minus 5 times x plus 5. And let's simplify that one more time. So let's see, I can combine the x's. So that's a negative x minus 15 all over my common factor of x minus 5 times x plus 5. Now, sometimes we want to multiply the denominator, but a lot of times it's just easier to leave things in a factored form. And it will depend on our question on when we need the question on what we're supposed to be doing, as well as the instructions, if we should be multiplying this out or doing anything further. But for my class, at least the general operation is getting a common denominator and then applying your operation. So the next one is one of those cases where it doesn't make sense to actually multiply them. So the LCD is not x cubed, because x times x is give you x cubed. Because the idea here is if you look at like the multiples of x and x squared, you can see that x divides into x squared and x squared divides into x squared. So the smallest denominator that they actually both divide into is x squared. See, in this case, they had nothing in common, right? Or they're like x plus 5 did not divide into x minus 5, and x minus 5 didn't evenly divide into x plus 5. So that's why we had to multiply them. But in this case, you can see that actually I can get away with just multiplying this left side by x over x. When I do that, I get a 2x minus x squared all over x squared plus 3 over x squared, right? So you could, there's nothing wrong with doing the LCD of x cubed and then multiplying this by x over x and this by x squared, but it's just more work that you're gonna have to simplify later. And now you can see that there's really nothing I can add up there. So I'm just gonna write those as one expression here. So we have a negative x squared plus 2x plus 3 all over x squared. And then actually, let's factor out this negative. So we had x squared minus 2x minus 3 all over an x squared. It's not going to help us simplify this. We could actually factor that, though. I'm not sure how that would help us out in this case, but you could write this as x minus 3 times x plus 1 over an x squared, if we needed to simplify it, or if you're looking for something special. But again, just that looking into applying the operation and then looking to further simplify things is something that could come up. So, typically that is going to be fine. We want to combine our operations. But again, just be on that lookout to be able to kind of further simplify things. All right, for the next one, the complex fraction. So we don't have any variables here. We're just going to deal with some numbers and just kind of practice some things. Like, a complex fraction is basically when you have a fraction with more than one fraction. You have fractions within fractions. So there's a couple different ways we could do this. You could convert the 1 into a 5 over 5 plus a 4 over 5 over 3 over 5. And then you could just now combine these fractions to 9 over 5 divided by 3 over 5. And remember, when you're dividing by fractions, the same thing as multiplying by the reciprocal. So therefore, that just gives you the answer 3. And that's nothing really wrong with that. Another way, though, that we could also do this is we notice that another way that I like to do it is just get rid of the denominators. So you can see in this case that our least common denominator, we'll just do LCD, is equal to 5. So if I multiply everything times 5, watch what happens. I get 5 plus 4 over 3, right? So if I multiply everything times 5, then I actually just eliminate all of my denominators. Now I just have one simple fraction, which is 9 over 3, which is just equal to 3. So we can apply the fraction operations, but a lot of times when we have multiple fractions, I like to think of this as just getting rid of the fraction. And then letter F just kind of comes into, I already kind of set us up over there. But again, it's just one of those common things that, a lot of times we're trying to apply operations to, an integer and a fraction. And we just remember we can always write our fraction or numbers as a fraction. So I can just rewrite 1 as 4 over 4 minus 5/4. Now I can combine those fractions to give me a negative 1/4. All right, so now let's get into the solving quadratic equations. And this was really important because I wanted to kind of go through the different kind of phases of solving quadratics because it's one that gets a lot of students tricked up all the time. Notice in the first 3 examples, there's only one x squared, right? So all I have to do is just use my inverse operations. I can just add 1 to both sides. Then I have 4x squared is equal to 1. Then I divide by 4. On both sides, therefore I'm left with x squared equals 1/4. Now I just undo squaring by introducing the square root. Now remember the rules of square roots. If you have the square root of a over b, that is equal to the square root of a over the square root of b. So therefore, I get x squared, and again, also remember you have to include the plus or minus, right? So x is going to equal plus or minus the square root of 1 over the square root of 4, which is really plus or minus 1/2. Okay, because you can square root of 1 is 1, square root of 4 is 2. The next example, kind of do the same thing. We're going to add a 3 to both sides. Then we have 4x squared is equal to 3. Divide by 4, divide by 4. So now we have x squared equals 3/4. Introduce the square root. X is equal to plus or minus the square root of 3 over the square root of 4, which can be simplified to plus or minus the square root of 3 over 2. Okay, so again, it's nice when we only have this x form, we can just undo our operations using the reverse order of operations. So we'll add 1 here. 2x squared equals positive 1. Divide by 2. X squared equals, x squared is equal to now 1/2. And now I'm going to introduce the square root. So x is going to equal plus or minus the square root of 1 over the square root of 2, which equals plus or minus 1 over the square root of 2. And just like in last class period, we're going to want to rationalize that denominator. So we'll get plus or minus the square root of 2 over 2. So I've already shown a lot of rationalizing the denominators, so that's why I'm kind of getting to that step. But just some important operations to kind of get to, or at least understand when you only have that one x. So the next round, we have 2 x's. So we can't use our inverse operations. Like the biggest mistake I still see people do is they'll add an x to both sides and they get like x squared equals x, and then they square root both sides and they're like x equals plus or minus like square root of x. And it's like, no, that's not going to work. We can't answer our questions with that. So we have to understand when we have more than one x, unfortunately, we got to go back to our factoring days. So we need to factor out what they have in common. And in this case, they just have an x in common. So by factoring out an x, I'm left with an x times x minus 1 equals 0. But now I have a product equal to 0. So therefore, I can apply the zero product property. So I can say x equals 0 and x minus 1 equals 0. Therefore, x is equal to a positive 1. And voila. Very, very little work that I had to do. In the next example, I have a negative 2, x squared minus 2x. So again, I'm going to subtract out a negative 2x. So now not only do they have an x in common, but also a negative 2. So by factoring on a negative 2x, that's going to leave me with an x minus plus 1 equals x. Equals 0. Now, it's very important. Like, I just know I made a little mistake, right? But I immediately checked my work. And what I did was I multiplied the negative 2x times x, okay? And negative 2x times positive 1 is going to give me negative 2x. So again, you can always check your work on factoring by actually just multiplying everything out. Now, it's important here when I use my zero product property. I guess I probably should have showed my work here, right? Let's just write that down here. Again, all I was simply doing is adding a 1 to both sides, okay? So here, you're going to divide by a negative 2. but you're still going to get x equals 0. So you can see that negative 2 is a scalar. It doesn't actually change my 0 here. In this case, I'll subtract a 1 on both sides, and x equals negative 1. All right. The next one here, now we're going to factor out a positive 2. We don't want to factor out a 4 because 4 doesn't factor, evenly divide into 2. So we're just going to factor out a 2x again, positive 2x. So that'll give me an x plus 1 equals 0. And therefore, I can say 2x equals 0 and x plus 1 equals 0. And therefore, you can say x equals 0 and x equals negative 1. Okay? So you can see, oh, wait, no, hold on. Factor out the 2. My bad. I factored out wrong. 2x times x does not give you 4x squared, right? Haha, I made a mistake. That should be a 2. I knew I was wrong. I was like, why am I getting the same answers? I didn't create this to have the same answers. This should be a 2x. 2 times 2x is 4x squared. 2x times 1 is 2x. Good job. So it's a 2x plus 1 equals 0. Now I have to subtract 1, then divide by 2. So x equals a negative 1/2. A lot going on. All right, so, but when we had two terms, we could just factor out a common term, and then that automatically rewrote our expression as a product, and therefore we could apply the zero product property. In the next round, we could see that we have trinomials, and hopefully you remember from our factoring practice that trinomials can be factored into a product of two binomials. But again, you notice that every single time of these, this is a product equal to 0. So all we got to do is figure out what are the numbers that create these two binomials that we can multiply to give us this. And notice how I did a is not equal to 1. Okay, so we're picking this up a little bit. Now again, if I need to get my first two terms, how do we get 2x squared? Well, that comes from multiplying the first two terms. So that's going to be a 2x and an x. How do we get the last two terms? That is from multiplying, or how do we get a negative 1? That's from multiplying the last two terms. So that's going to be a -1 and a +1, right? To get a negative one number has to be positive, one number has to be negative. The problem is we don't know which one. Should we do a -1 here and positive 1 here, or should we do a positive 1 here and a negative 1 here? And again, a lot of this, you could just do both and then figure out which one does work. And for a lot of students that struggle with that, I would recommend just practicing that. What I like to do is look at the middle term. And since the middle term is positive, I know that the product of my inner and my outer need to add up to a positive x. So therefore, my product, the larger of my two products for inner and outer needs to be positive. So if I know I'm going to be multiplying a 2x times 1 and an x times 1, well, that's going to be a larger product. The 2x times this positive 1. And this is going to be a smaller product. And again, we're combining those together. When you FOIL, or you distribute property, you combine those middle terms, and you're going to get a, so those middle terms will add to give you an x. And again, you can just do a quick check. 2x times x is 2x squared. -1 times +1 is -1. Negative x, positive 2x. Positive 2x plus negative x is a positive x. But now I have a product equal to 0. So 2x minus 1 equals 0, and x plus 1 equals 0. Therefore, add 1, divide by 2, x equals 1/2, x equals -1. So the next one, we see a trinomial, we're say, okay, same thing. But now in this case, notice my middle term is negative. So since I already did this work, I say, oh, it's going to be the exact same thing, right? Except now the larger of my inner and my outer needs to be negative. So I want this to be negative, that to be a +1. And again, go and check your work if you don't believe me, but it's right. So 2x plus 1 equals 0, and x minus 1 equals 0. Therefore, x equals -1/2 and x equals +1. Now in the next example, again, we see this 2x and 1. So I say, well, all right, it's going to be a 2x again and an x. The last two terms is +1. So that could be a +1 and a +1, or a -1 and a -1. And I look at my middle term, and since my middle term is positive, my two 1s have to both be positive. So therefore I have 2x plus 1 equals 0 and an x plus 1 equals 0. So therefore, x equals -1/2 and x equals a -1. All right, so for the last one is just evaluating based on the unit circle. So we really need to make sure we remember the first quadrant of the unit circle. So I'm not going to go through all of these angles. I don't have enough room to kind of rewrite them out there. But I told my students in our trigonometry unit they needed to know these coordinate points and the angles that they refer to. They also need to remember that the cosine of an angle represented the x coordinate, the sine of an angle represented the y coordinate, And the tangent of an angle represented the y over the x on the unit circle. So those are definitions when we had points that were on the unit circle. So square root of 3 over 2, comma, 1/2. This one was square root of 2 over 2, comma, square root of 2 over 2. And the last point was 1/2, comma, square root of 3 over 2. Okay, so remember the first angle is pi over 6 or 30 degrees. The second angle is, let's actually see if I can write that in there. Pi over 6. Next angle is pi over 4 or 45 degrees. This angle was pi over 3 or 60 degrees. And this angle was pi halves or 90 degrees. Okay, so I'm not going to rewrite those all from there because I just want to kind of get through these answers as simple as possible because, again, when we kind of get to this chapter, we want to know the cosine of pi halves is the x-coordinate at pi halves, which is just 0. The sine of pi over 4 is the y-coordinate for pi over 4, which is square root of 2 over 2. Tangent of pi over 6 is that's going to be the y-coordinate over the x-coordinate. Oops. And the y-coordinate over the x-coordinate, since we've already done this multiple times, is going to be square root of 3 over 3. The tangent of 0 is the y-coordinate over the x-coordinate, which is just 0. Tangent of pi over 3 is going to be just the y-coordinate, so that's going to be square root of 3 over 2. And the cosine of pi over 3, that's going to equal 1/2. So now let's just get to the angles, or now we have angles that are in degrees. So same kind of idea, just in degree form. So 30 degrees, that's going to the same thing as pi over 6, so that's going to be square root of 3 over 2. The sine of 60 degrees, that's the same thing as pi over 3, so that's going to be a positive 1/2. 45 degrees, that's the same thing as pi over 4, so that's going to be square root of 2 over 2 divided by the square root of 2 over 2, which is just 1. Let's actually simplify that out. Okay, sine of 90 degrees is the same as pi halves, so that's going to equal 1. The tangent of 60 degrees, that's the same thing as pi over 3, so that's going to be the y-coordinate, which is square root of 3 over 2 divided by 1/2, which gets simplified to square root of 3. And the cosine of 0 degrees is the same thing as 0 radians, really not moving anywhere, and that's just going to equal 1. So there you go, ladies and gentlemen. That is some problems that I have designed to help you with your analytic trigonometry chapter, and I hope that now when we get to some problems, you'll feel a little bit more comfortable as we work through the chapter. And I wish you the best of luck, and I'll see you on the next video. Cheers.